We are solving two questions from photoelectric effect, that is from dual nature of matter. The questions are given in NEET, the prospective years. The first question says, light of frequency 1.5 times the threshold frequency is incident on a photoelectric material. What will be the photoelectric current if the frequency is halved and intensity is doubled? Let's have a look at the things that what happens is, when a light of suitable frequency with a certain energy E, which is expressed in terms of photons as h nu, is incident on a metal surface, it is used in two phases. First, some part of the incident energy is used to remove the electron from the metal surface, and that energy is called work function. After that, if the incident energy is more than the work function, there is extra energy available for the light. That extra energy works like a kinetic energy, right? So if energy is greater than work function, kinetic energy is available. What we can say is E equal to h nu equal to work function equal to h nu naught plus kinetic energy equal to half mv square. This is the Einstein's photoelectric equation, Einstein's famous photoelectric equation. Now, when a light of frequency 1.5 threshold frequency incident, there is a photoelectric current, right? If incident frequency is 1.5 times of threshold frequency incident on a photon surface, there is some photoelectric effect. He is asking, what if what is the photoelectric current if the frequency is halved? If nu dash is original frequency is 1.5 times of threshold frequency, that is halved, that is 0.75 times of nu naught. So in this case here, incident frequency is less than the threshold frequency. 0.75 times 0.75 means 3/4 of it. As the incident frequency is less than the threshold frequency, whatever may be the intensities, when the intensity is doubled, there is more photoelectrons available, but each one with an energy with a frequency less than the threshold frequency. As the incident frequency is less than threshold frequency, given energy E is not sufficient to remove the electron from the work function. That means incident energy is less than work function. That means there is no photoelectric effect. No photoelectric current is emitted there. So the photoelectric current will be 0. Right? That is a simple conceptual question. Let's have a look at the next question. The work function of a photoelectric metal is given for you as 4 electron volts. The longest wavelength of the light that can cause photoemission from the substance is how much? That's what is being asked, right? So what is given for you is a work function. What do you mean by work function? We have to understand. Here also we said about work function. Work function is the minimum energy required to emit electron from a metal surface. Who has to give this energy? The incident energy has to give that energy. So work function is, as we have written earlier also, h nu naught, where nu naught is called as threshold frequency. That's the minimum frequency, right? So if the incident frequency is less than threshold frequency, incident energy is less than work function, and there is no photoelectric effect. This work function is given for you in the problem as 4 electron volts. Then what is the longest wavelength of the light that can be used for this photoelectric emission is, right? So you can write energy is h nu, that equal to hc by lambda. So you can substitute the values of hc and get a calculation, and you will get energy in terms of joules. But if it is converted into electron volts, it becomes something like, after substituting the values and simplifying, this becomes a standard number, standard equation, lambda in angstroms. So whenever you are expressing lambda in angstrom and you want energy in electron volts, you can use this relation. So this is an important relation in photoelectric effect. Here energy is given for you in 4 electron volts. So this implies what we can say, 4 electron volts equal to 12,400 by lambda automatically in angstrom. It implies lambda in angstrom equal to 12,400 by 4, that is 3,100, right, in angstrom. But you want the answers everything in nanometer. Nano means 10 power minus 9. Angstrom means 10 power minus 10. So you can write it as 3,400 into 10 power minus 10. So you can write this as 3,100 into 10 power minus 1 into 10 power minus 9. So this is 3,100 into 10 power minus 9 nanometer. That is 310 nanometer. So answer for that problem is 310 nanometer. That's how we have to solve that problem. Thank you for watching.